Everyone, this is Amir and this is the first video ever from my side. And I'm really excited to explore these amazing papers and models, and that is going to be our theme for the coming videos. So there's going to be a model and a paper, and yeah, it's a pleasure to meet every one of you. But before we go into discussing HuggingGPT, let's discuss what is AGI. So AGI stands for Artificial General Intelligence. Obviously, this idea of one model being able to perform a number of general purpose tasks, that is somewhat the idea of AGI. But the definitions vary a lot. For example, it can be a model which can do everything that a human can do. So that's the definition. Another definition can be if AI is able to perfectly imitate a human such that the human is unable to tell whether it's a human or an AI, then it's also called AGI. So this was by Alan Turing. And there are actually much deeper definitions. For example, software updating its hardware. So we don't see that currently, but that might happen in the future. But the type of definitions that I would like to consider in the present moment is actually taken from Demis Hassabis, the founder of DeepMind. And he actually said on a podcast that a couple of things which will really fascinate or blow his mind, or he would call that AGI. The first one was that if an AI is able to discover something new about the world, such that it deserves a Nobel accolade, that would be really groundbreaking, and I agree with that. But another definition which he said was a model which is able to do many general purpose tasks. He would also call that AGI. Okay, let me just first tell you what HuggingGPT is in a nutshell. So basically, there's this idea of one model, which is here is ChatGPT, that's able to control many other models within HuggingFace. So why would we want to do something like this? Like, why is not ChatGPT enough? So first of all, there's this issue of modality. Like ChatGPT, even GPT-4 right now, is limited to just text. It doesn't offer support for audio or image, etc. So it's very restricted to one modality. The second thing is that there's no idea of task planning. So if there's a complex task, it's possible that the model has to break it down into smaller pieces in order to execute it. But currently there's no idea of task planning within ChatGPT or GPT-4. And finally, there's this idea of specialization. So these models, which were trained early by, thousands of people and are open source, these are in a way specialized models. So I'll give you an example. Suppose you want to detect whether someone has skin cancer or not. So ChatGPT is obviously not able to do this. Maybe GPT-4, which can see images, is also not able to do it. Why is that? Because it's not trained on that data. It's not specialized to do that task. So a model within HuggingFace, which is able to recognize these kind of skin lesions for skin cancer, might be able to detect it. That's where the specialization comes in, that this ability of one model, which is like the brain, and it's able to switch between multiple or thousands of models in real time. Yeah. So, I would like to jump into the first steps which are involved in the working of HuggingGPT. So the first step is called task planning. The ChatGPT actually determines the order of execution of different models, and here we need actually 4 things. First thing is the task ID. So that is randomly generated. Second thing is the task type. So these are just categories, whether it's a text task, it's an image task, or an audio task. Then task dependencies. So these are the prerequisites that are required for this in order for this task to be performed. And finally, the task arguments, which will go into this function in a way. And again, these arguments can be in the form of text, image, or audio. Before we move on to the second step, there are actually 2 important processes within task planning. First thing is specification based instruction. So here the user can explicitly specify what do they intend to do within the prompt. And then there's another process which is demonstration based parsing. Here the model can access its previous chat logs and it's able to determine which is the optimal model. The second step for the working of the model is model selection. So the model selection happens based on not only the description, but there are other key areas which are considered, such as functionality, architecture, and licensing. So it's much broader than the OpenAI plugins. Alright, in this step, a lot of potential models are presented and they are filtered by task type, and they're also filtered by the number of downloads. So in this way, number of downloads is kind of an indicator of the performance of the model or the efficiency of the model. The third step is the task execution itself. So there's something called hybrid inference endpoints. So there are two types of hybrid inference endpoints. The first thing is, okay, where will the inference be actually performed? It can either happen on a local device, or it can either happen on HugginFace. So if it happens on HugginFace, then the choice of models is obviously large, but the inference time can be high. That's why the latency can be high. And the exactly opposite is applicable to a local device. The inference can be faster, but there's lesser choice of models there. The final step is response generation, where all the model outputs are collected and ChatGPT basically frames an answer, which is the most appropriate one. Touch on just a few examples before we go forward. And the first example that I would like to mention is, the first example that I'd actually like to mention is the following. So here we asked it to generate a video with the title "An astronaut is walking in space" and dub it. So a few things are happening in this prompt. Basically, we take in text and we want video and audio as output. So it's using a couple of models called text to video, and so it converts the text to video. Similarly, converts the text to audio using this model. And finally, it combines both of them, and we get the following output. Yeah, that is the first example, and we can move on to the second one. Alright, so I found this one really fascinating. This is the second example, and basically you were able to find out, so the prompt is, look at the document, this one, what is the purchase amount? So you're able to extract some particular information from the document, and the model uses this one, layout LM document QA, and it was able to successfully carry out this process. This is the final example, and the prompt is, describe this image in as much detail as possible, and this is the image. So it actually uses multiple models. So it uses this one for image to text, where it generates captions, and it comes up with this one. And then it actually uses another model to classify the dogs. Then again it uses another model to basically build bounding boxes around every dog so as to count them. And then it finally uses the Dandelion fine-tuned VQA model, which is for a visual question answering task, and it asks itself like what are in the image and reply against dogs. So basically it wants to be sure, as we said, as we wanted a lot of detail from this image from our prompt, it wants to be sure. That's why it uses multiple models, and then it does task planning and task execution. And finally it collates it and gives us the following answer, which is a family of 4 dogs playing in grass, which is not bad. And as you can see, it used multiple models for accomplishing this task.